Got these 5 questions out from yesterday? In the interest of time, I'm not going to do every restriction. Okay? So, if you were doing number 1, which you all did, would you try to simplify the green? Would you try to get rid of the green radical first or the yellow radical first? Green? I would too, because it's the more complicated one. All right? Now, if you got rid of the yellow one first, you're going to follow the same steps. Your work's just going to look different until you get down to the bottom, and then you're going to have the same answer. All right? All right. So if I'm going to simplify the green one first, I got to get rid of that 5, right? So I'm going to bring that 5 scooching all the way over to here, and what's going to become of that positive 5? It's going to be minus 5, and I'm going to have 2 plus root 3x equals root 5x plus 4. Now, I'm going to square. Now, for the approximate 100,000th time, this is not 4 plus root 3x. All right? This is 4 plus 4 root 3x plus 3x. Okay? All right. Now, right away, you see you have a 4 on one side and a 4 on the other side. What can you do? They can disappear. And now I've got this. I got a 3x, I got another 3x, or another x. So that's going to go over there. And I'm going to get 4 root 3x equals 2x. Right? Now, you have a choice. You could divide by 4, but that's going to give you a fraction, which makes most of you pee your pants a little. So, I would, in this case, just square both sides. And you will get 16, right? Because 4 times 4 times what will be here? When I square root 3x, what will I get? 3x. And over here I will get 4x squared. Then I would bring this over here to get 4x squared minus 3x plus 16. And then I would factor. Now, I am feeling very sick, and I screwed this question up earlier, and I'm not 100% sure I've done it right this time. If we get to here, we would factor. We need to multiply to 64 and add, yeah?
Why does it become like minus? Because in the first slide nowadays it says 16 times 3x.
Oh, of course. See? I knew it. Man, that's 48x. Thank you. 4x squared minus 48x equals 0. And now you take out a 4x, and you get x minus 12 equals 0. Right? Now, for this to be true, x would have to be what? Everyone knows right now x equals 12 because of that. But I bet at least half of you forgot about this x. What is the other root here? Zero. Because 4 times 0 makes this 0. It doesn't matter what this is. Right? So we check them both. Do they both work? Do they both work? What's the square root of 4? What's the square root of 4? Plus 5? 7. What's 3 times 12? 36. What's the square root of 36? What's 7 plus 6? Is 13 the same as... Oh, wait, I just used 12 and 0. See? 5 times 12 is what? 60. Plus 4? Square root of 64? 8 plus 5? 13. 7 plus 6, 13. Does 12 work? Yes. 0 plus 4 is 4. Square root of 4? 2 plus 5? 7. 7 plus the square root of 0 is what? 7. Do they both work? Yes. I don't care about the restrictions today. This one. If I were doing this one, I would bring this over here. And I would get negative 3 root n minus 1 equals negative 21. Now, some of you are going to square this because you see the radical isolated. That'll work, but I would get rid of this negative 3 first because this division works. And I get n minus 1 equals positive 7. Now n minus 1 equals 49, and n equals 50. And then I check. What's 50 minus 1? 49. What's the square root of 49? What's negative 3 times 7? Negative 21. What's negative 21 plus 7? Does negative 14 equal negative 14? And I'm right. This one, I would move this to get 15 equals 5 root 8 minus x. Then I would get rid of the 5. Why? Because this one actually divides. 3 equals root 8 minus x. 9 equals 8 minus x. 1 equals negative x. So x equals negative 1. And then I check. What is 8 minus negative 1? 9. What is the square root of 9? What is 5 times 3? What is 15 minus 3? Does 12 equal 12? We're right. This one, they're already isolated, so all I got to do is square both sides. Z plus 5 equals 2z minus 1. So z equals 6. Check it. What's 6 plus 5? 11. So that's root of 11, right? Doesn't have a root, so we got to leave it. What's 2 times 6? What's 12 minus 1? Does root 11 equal root 11? So we're right. Now, this one is trouble. Because some kids in my other class still did this. And had the nerve to tell me that this left side was x plus 19 plus x minus 2 equals 49. The nerve. Right? Because none of you did that, did you? Because damn right you got a fat stack of work. You're going to make it rain with numbers and such. Oh, I just erased the question. What was it? Same. So, of course, I do this. 7 minus root x minus 2. Square both sides. Equals 49 minus 14 root x minus 2 plus x minus 2. Right? Then I collect my like terms. Positive x, positive x. What do I get to do? Cancel. 49 minus 2 is 47. 47 minus 14 root x minus 2 equals 19. I, of course, don't like that negative 14, so I take all this over here. I take this over here, and I get 14 root x minus 2 equals 28. Root x minus 2 equals 2. X minus 2 equals 4. X equals 6. What is 6 plus 19? Square root of 25. 5. What is 6 minus 2? Square root of 4. What's 5 plus 2? Does 7 equal 7? Yay! And I'm a genius. Then I gave you some factoring that I've lost. Yo. Yeah. All right. Now, as about a third of the class now knows, thanks to Sam's vehement support of it, this is a difference of squares, which is exactly the same as a squared minus b squared, which is, of course, a plus b, a minus b. So, if this is a, it is 2x plus 3 plus, that's b, 4x minus 7. That's the first factor. The second factor is 2x plus 3 minus 4x minus 7. Then your grade 9 math brain takes over because you see 2x plus 4x to get 6x. Then you see 3 plus negative 7 to get negative 4. Then you see 2x minus 4x to get negative 2x. And you see 3 minus 7 to get 10. Then, of course, you see, wait a minute, I can take a 2 out of there and get 3x minus 2. And I can take a 2 out of there to get 5 minus x. And then you say, if that's a factor and that's a factor, 2 times 2 must be 4. Now, some of you will have a negative 4 there. You'll have negative x plus 5. I don't care. What is all the chit-chat? I find myself wondering myself. This is, of course, the exact same question, because this is an x. That is an x. So what you really have there is x squared minus 4x minus 45. So you need to multiply to negative 45 and add to negative 4. What is it? Is it 1 and 45? Is it 3 and 15? Is it 9 and 5? Of course it is, because 5 minus 9 is negative 4. So what you have is x minus 9 and x plus 5. But the x's are not x's. What are they? 4x plus 3 minus 9, which is 4x minus 6. And 4x plus 3 plus 5, which is 4x plus 8. Then, of course, you see, oh, out comes a 2, out comes a 2, and I get 4, 2x minus 3. I lie, out comes a 4, and I get 8. x plus 2. Now, just to put your minds at ease, these factoring questions are way tougher than what's on your test. Why? Because if you practice tough, the game is easy. This was a difference of cubes. My good friend Crystal spotted that, and she said to herself, "Self, I know that a difference of cubes is the square root of the first one minus the square root of the second one times the first one squared plus them both multiplied together plus the second one squared." So she went here and she said, "I know what the cubed root of 64x to the sixth is. It's 4x squared." Then she said, "I know what the cubed root of y to the sixth is. It's y squared." And then she said, "Oh, I got to take x and square it." Well, x is 4x squared, so that's 16x to the fourth. Then I got to multiply them together. That's 4x squared y squared. Then I got to do the second one squared, which is y to the fourth. Then she said, "Wait a minute. That's a square. And that's a subtraction. And that's another square." And then Sam ran up to the front and said, "It's a difference of squares. It's a difference of squares." And Sam saved the day. And Crystal wrote 2x plus y, 2x minus y, times 16x to the fourth plus 4x squared y squared plus y to the fourth. Way to go, Sam and Crystal.
Oh, yeah. Wait, okay, no.
Went on a diet. Now this one is the exact same, of course. X squared minus 4, x to the fourth plus 4x squared plus 16, and then x plus 2, x minus 2, x to the fourth plus 4x squared, plus 16. Then we got to here, and this was the same as up there, because that's x. And you knew that it was x plus 6, x plus 2, but it's not x. It's 2x plus 7 plus 6, which is 2x plus 13, and 2x plus 7 plus 2, which is 2x plus 9. And then you got to here, and you saw, "Oh, Mr. Myers, stop trying to fool me. You just embarrass yourself when you try to fool us, because you've taught us so well that we can kick these questions' asses, and now you look like a chump for trying to fool us." Because this, of course, needs to multiply to negative 12 and multiply to negative 60 and add to 11. Of course you know it is 15 minus 4. So of course you know it is x plus 15 over 5 and x plus negative 4 over 5, which is x plus 3 and 5x minus 4. But x is 2x plus 3, so that's 2x plus 6. And that is 2x plus 3, which is 10x plus 15 minus 4, which is 10x plus 11. Then, of course, you factored this out and got 2x plus 3, 10x plus 11. And then you were done because you were feeling lightheaded from having to talk that long. This is the same as 5x squared plus 11x minus 12. You would factor that and then sub back in. What do you think these last 5 days have been? Test reminders. 1, factor. Right? Factoring. GCF, which is always the same thing. AX plus AY, and so on. Divide by A to the front, X plus Y, and so on. That's GCF factoring. Every fact in math is a fun fact, because math is fun. The next factor is trinomial. X squared plus bx plus c. Multiply to c, add to b. Then there's trinomial ax squared plus bx plus c. Multiply to a times c and add to b. Then that's going to give you either a fraction, x plus m over n, and the n will move to the front, and x plus p over q, and the q will move to the front if you do it that way. Or maybe you do it the other way I showed you this year, which is ax squared plus m and ax squared plus m, and then you look for GCFs. And the last one is, of course, there's 2 more. Difference of squares, which is a squared minus b squared, and that is the square root of a squared plus the square root of b squared. And then the same thing, but with a minus. And the diff of cubes, which is x cubed minus y cubed, equals x minus y, x squared plus xy plus y squared. The sum of cubes is x cubed plus y cubed equals x plus y, x squared minus xy plus y squared. And then radical equations. Which is 1, isolate radicals. This is all being recorded for those of you who are not totally paying attention. I'm going to put an S in brackets because sometimes there's more than one. 2, eliminate radical by squaring. Be careful, square both sides. Number 3, find x with algebra or factor for x. And 4, remember, it's got to be x. It's got to be some math equals 0, so you can deal with x. And that's everything you need to know for your test tomorrow. You're all going to do wonderfully on it, but even if you don't, it's not going to matter. Why? Because what's happening next Friday? Cumulative. Wow. Yes. Over the moon. It's actually my favorite indoor sport. I love handball. I don't understand why handball isn't super popular in North America. It's got everything basketball has, but better. Yeah, I know. I don't know why there can be professional handball leagues all over the world, but not here. Don't even get me started about dodgeball. Dodgeball is lame. It never should have become anything but a gym class game.